Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from March 2024, Paper 1, Variant 2. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. In order to get maximum benefit from these videos, always pause the video, do question by yourself and then look at the solution. And if you have any doubts, if you have any questions, please leave your questions in comments, then I will try to answer as soon as possible. Let's study together, let's improve together. Question 21 says a spring is fixed at one end and extended by applying force F to the other end. The spring has extension X and elastic tension energy EP. The spring constant is K. The spring obeys Hooke's law. Which relationship is correct for this spring? So first of all, simply we can sketch this one because it's very important to visualize. So simply we can sketch this one is the spring. So this is spring, and then we apply force F on this spring, and when we apply force F on the spring, this spring extended. So simply we can say it extended, and this is value of X, so this is value of extension, so this is given to us X. Then elastic tension energy stored in this spring is EP. We need to find the relationship between EP and X. So we need to understand EP, this is equal to 1/2 kx square. 1/2 kx square, so in this case you can see this is constant. So simply we can say EP is directly proportional to x square. So this is relationship between X and EP. So the answer for this question should be D. Let me explain you a little bit about this one, how we derive this formula. EP is equal to the work done on the spring, and work done is equal to the average force time the distance travel, mean that is X. Distance travel in this case is X, means spring is extended by this amount. Average force in this case will be equal to the maximum value of the force plus 0 divided by 2 and multiply by X. This is extension. F max is equal to F, so this is F divided by 2 times X. But F is equal to by Hooke's law, F is equal to Kx. So simply we can replace F with Kx. So here we have K times X, and here we have X. This is divided by 2, so we will have K times X squared divided by 2. So this is EPE, elastic potential energy. Most of the time student they understand this formula that EP is equal to 1/2 Fx, but they don't exactly understand the meaning of this force. This is the maximum force. So F is representing the maximum force on the spring. When we extend the spring, force is not constant, so F is the maximum force. Question 22 says a force extension graph is produced for a metal wire. What must describe the limit of proportionality of the wire? So first of all, we need to understand what is limit of proportionality. Limit of proportionality means that end of proportionality. Until that point, two quantities they are proportional to each other. After that point, they are not proportional. So that point we will say is limit of proportionality. End of proportionality means until that point two quantities are proportional, after that they are not proportional. Let's try to understand this one with the help of simple graph. So imagine that we have force on y-axis and let's say we have extension on x-axis. So if we sketch the graph, the shape of the graph should be somewhat like this. Until this point, two quantities are proportional. After that, shape of the graph may be like this. So this point, until two quantities are proportional, we will say this is limit of proportionality. And until this point, Hooke's law is obeyed. So we can also say Hooke's law is obeyed. So we can say in this region, Hooke's law is obeyed, and in this region, Hooke's law is not obeyed. Now if you look at given options, option A says the point at which the wire breaks, this is the breaking point, or we can say this is fracture point. So this is not correct option, so this is incorrect. Point beyond which Hooke's law is not obeyed, means after that Hooke's law is not obeyed, so this point is limit of proportionality. The point beyond which the wire cannot return to its original length, and after that point wire will deform plastically, we call that point is end of elasticity, means elastic limit. So that is elastic limit. So this is not possible answer. The point beyond which the wire starts to deform plastically, this is also elastic limit. Mean before that it is behaving elastically, after that point it starts behaving plastically, so that point is also elastic limit. So this is limit of proportionality. So let me write on here for your better understanding. So this is limit of proportionality. So this is, and this is another way to say is elastic limit as well. So this is elastic limit as well. Until that point it is behaving elastically, after that it is behaving plastically. So the answer for this one has to be B. I hope this makes sense. If these videos are making sense and helping you to improve, so please like and subscribe, and also share with your friends, because your encouragement play a very important role to make new videos. Question 23 says a spring has a spring constant of 6.0 newtons per centimeter. It is joined to another spring whose spring constant is 4.0 newtons per centimeter. A load of 80 newtons is suspended from this composite spring. What is the extension of this composite spring? Very nice question on springs. First thing we need to understand, the force here we have, means the load we have here, the same force as this spring is a massless spring. Our assumption is that springs are massless, so it means that force on this spring also is equal to 80 newtons. So let's say extension of this spring is x1, extension of this spring is x2. So total extension, so we can say total extension, that one has to be equal to x1 plus x2. You can also treat these two springs individually. You can simply imagine we have spring 1, force on this spring here, this force is 80 newtons, and spring constant of this one is given, that is 6.0 newtons per centimeter. And the second spring we can also treat separately. We can simply imagine this is second spring, force on this one is also 80 newtons, and spring constant of this one is 4.0 newtons per centimeter. So we can calculate extension of this one. We can say this is spring 1 and this one is the second spring. We can calculate extension of this one, that will be x1. So x1 will be equal to force divided by spring constant, that is 6.0 newtons per centimeter. So this is in newtons. For the second spring the force is the same, so this is 80 newtons and spring constant is 4.0 newtons per centimeter. So in this case you can see newtons will be cancelled and we will get only centimeters. So if we solve this one, we will get 13.3 centimeters here, and here we will get 20 centimeters. So the final total extension, this will be equal to 33.3 centimeters. So this is our final answer. So this is how you can approach. You need to understand the concept, you need to understand the logic. So simply you can treat them two individual springs, you can calculate the extensions, then simply add them and you can find the total extension. So the answer for this question should be D. Question 24 says the range of frequencies of sound waves emitted by blue whales is 10 Hz to 40 Hz. The speed of sound in seawater is approximately 1.5 kilometers per second. What is the approximate range of wavelengths of the sound waves emitted by blue whales? Range of wavelengths. So first of all, we can simply write down here for 10 Hz. So we can write down here for 10 Hz. For 10 hertz frequency, we can find out value of lambda, that will be equal to V divided by F. And value of V we have, that is 1.5 kilometers. It means this is equal to 1500 meters per second divided by 10. So we will get this is 150 meters. For F equal to 40 hertz, we can also calculate value of lambda, that will be equal to 1500 divided by 40. So this 0 we can cancel with this one. So 150, if we divide by 4, we will get 37.5 meters. So this is value of lambda for this frequency. And here we have lambda for 10 hertz. So the answer for this question is 38 meters to 150 meters. Simply you need to use lambda is equal to V divided by F. Question 25 says a sound wave is detected by a microphone and displayed on the screen of a cathode ray oscilloscope. The frequency of the wave is 2.5 kilohertz. What is the setting on the time base of the CRO? So first of all, we have frequency that is equal to 2.5 kilohertz. We can calculate time period, that will be equal to 1 over frequency. So this is 1 divided by 2.5 times 10 to 3 hertz. If we solve this one, we will get 0.4 times 10 to minus 3, or we can say this will be equal to 4.0 times 10 to minus 4 seconds. Now we need to determine time base setting. Time base setting simply is equal to time period divided by reading on CRO. So the reading on CRO, we can see here, this is 1 centimeter. So we have, first of all, this is 1 centimeter, and we have another centimeter, we have another centimeter, and we have another centimeter. So this is the complete wave. So you need to find the length of one complete wave. So you can see this wave start from here. So this is one complete wave, and this is equal to 4 centimeters. So we can say this is 4 centimeters, and here we have 4.0 times 10 to minus 4 seconds, and this is divided by 4 centimeters. So this 4 we can cancel with this 4. So simply time base setting is 10 to minus 4 seconds per centimeter. Mean 1 centimeter is representing 10 to minus 4 seconds. We can also write down this one, 10 to minus 1 times 10 to minus 3 seconds per centimeter. So it means we can write down this one 0.1 millisecond, ms, milliseconds. So if you look at given options, option A is correct. So this is the right answer. If you have any questions, you can leave questions in the comments, and if these videos are helping you, please like and subscribe, because your encouragement is very important. And if you're looking for extra resources, you can also join Patreon.